Hey, what's up everybody? In today's video we're going to talk about an oversimplified version of sizing conductors for continuous load. We'll do a more in-depth explanation in another video, but first and foremost we need to find out what continuous load is. So the NEC defines it as a load where the maximum current is expected to continue for 3 hours or more. So what exactly does that mean? Well, basically, if you've got a motor that's going to be running at maximum current, or a lighting circuit, or some other kind of a load, and it's going to be running for 3 hours or more at its max amperage, then it's considered a continuous load. So why is this important to know? Well, we want to make sure that we're compensating for heat and protecting the wire, and to do that, you need to make sure that you're sizing the wire correctly. So let's take a quick look at how we do this. Let's say that we've got two loads on the same circuit. Load number one is a single phase half-horse motor rated at roughly 10 full load amps. And we're going to consider this one non-continuous because it never runs for more than 3 hours at that 10 amps. Now load number two is going to be a single phase 5-horse motor, and it's rated roughly at 56 full load amps. This one will be considered a continuous load because it typically runs for 4 hours at a time at that 56 amps. So how are we going to size this? Well, if both loads were non-continuous, both motors were non-continuous, we just simply find the wire size that would accommodate 66 amps. Go to Article 310.15 in the NEC, and if we're using 90 degrees C THHN copper, you would use a number 6 wire because it's rated at 75 amps. Now a number 8 is only rated at 55 amps. That's why it won't work. So we go with the number 6. But in this example, we have one load that is continuous load. So we got to rethink how we're doing this. Back to the NEC, Article 210.19, it states that the minimum branch circuit conductor size shall have an allowable ampacity not less than the non-continuous load plus 125% of the continuous load. So let's break down the math. If we have the same two motors, motor number one is still going to pull 10 amps. But now we've got to take motor number two's 56 amps, and because it is a continuous load, we've got to multiply it by 125% or 1.25. So that brings us up to 70 amps on motor number two. So now we add 70 amps plus 10 amps for a grand total of 80 amps. If we go back to our chart in the NEC at 310.15, we're going to see that we need to upsize to a number 4 conductor if we're still using the 90 degrees C THHN, because the number 6 is only rated at 75 amps. Now there of course are a few other factors dealing with the temperature, but we'll get into that in another video. But this just gives you a simple breakdown of how to configure conductor size with a continuous and a non-continuous load that are on the same circuit.
Hey, thanks for watching this quick tutorial. Make sure you head over to electricianslibrary.com and check out the Weekly Buzz. It's my weekly podcast dedicated to electrical trades, and hopefully we're sharing something fun with you over there. So head over there, check it out. You can also subscribe on iTunes, and if you would, please make sure that you give us a 5-star rating and help us out there. So thanks again, appreciate you coming over, and we'll see you next time. Till then, stay grounded.